Hi dear students, today we are going to discuss the periodic classification of elements, so previous year questions for TS. So first question చూడండి. First one, in which of the following the elements are correctly arranged with respect to their negative electron gain enthalpies? So first, what is electron gain enthalpy? Electron gain enthalpy or electron affinity, both are same. Electron affinity or electron gain enthalpy means if you take an isolated neutral gaseous atom, isolated means single, there is no charge present on atom, so that's why it is called as a neutral. So isolated neutral, it is exists in gaseous state. So isolated neutral gaseous atom, if you add an electron, to the isolated neutral gaseous atom, it releases some energy. That energy is called electron affinity or electron gain enthalpy. The energy is released when you add an electron to the isolated neutral gaseous atom is called electron gain enthalpy or electron affinity. Which elements have electron affinity is very high? Those elements has small size. Those elements are very small, not very small size. That elements has highest electron affinity. So very small elements have less electron affinity than the small sized atoms. So that is the difference. So that's why if you take halogens, fluorine, chlorine, bromine, iodine, astatine, top to bottom size increases, electron affinity increases. Top to bottom size increases, electron affinity decreases, because lower atomic size elements have higher electronic affinity. Fluorine has very small size. If you add an electron, the electrons present in the fluorine atom repel by adding electron. Added electron and the electron present in the fluorine atom repel with each other. Some energy is required to add an electron to the fluorine atom. That's why fluorine is very small. Electron affinity is somewhat decreases when compared to chlorine. Chlorine small, fluorine very small. That's why in every group, second element has higher electron affinity than first element. So fluorine, chlorine, when compared to fluorine and chlorine has more electron affinity. So if you take the given elements, phosphorus, sulfur, chlorine and fluorine. So when you write the periods, so second period elements are beryllium, boron, carbon, nitrogen, oxygen, fluorine, next neon. Third period elements, so here lithium. So next third period elements, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. So the given elements are phosphorus, next sulfur, next chlorine, fluorine. Point note cheyandi, in periods left to right electron affinity increases because atomic size decreases. So when compared to phosphorus and sulfur and chlorine size is small, so chlorine has more electron affinity. So in top to bottom, second element has highest electron affinity than the first element. Chlorine has highest electron affinity. So after chlorine, fluorine next highest. So when compared to fluorine, sulfur and phosphorus has least electron affinity. So next sulfur, next phosphorus. Why phosphorus when compared to sulfur electron affinity is less? Phosphorus when compared to sulfur, atomic size of phosphorus is more. More atomic size means less electron affinity. That's why the electron affinity order is PSFCl. So PSFCl. So answer is C. Next, choose the correct order of second ionization enthalpies of carbon, oxygen, nitrogen and fluorine. Ionization enthalpy, it is electron gain enthalpy, it is ionization enthalpy. Ionization enthalpy means same model. If you take an isolated neutral gaseous atom, to remove an electron, some energy is required because this electron is attracted by the nucleus of an atom. To overcome that attraction, the energy is required. So the minimum amount of energy required to remove an electron from an isolated neutral gaseous atom is called ionization energy. So that is first, if you remove first electron, that is first ionization energy. If you remove the second electron from the unipositive ion, that is called second ionization energy. So carbon, oxygen, nitrogen, fluorine. Carbon atomic number 6. So electronic configuration, valence electronic configuration 2s2, 2p2. Valence shell electronic configuration. Oxygen atomic number 8. Valence shell electronic configuration 2s2, 2p4. Nitrogen 2s2, 2p3. Fluorine 2s2, 2p5. So after carbon, here nitrogen, next oxygen. Because carbon 6, 7, 8, 9 to 2p3, 2s2, 2p4. We know that left to right atomic size decreases. When atomic size decreases, to remove an electron, the attraction between nucleus and valence electron increases. Size decreases, attraction increases. When size increases, attraction decreases. Size decreases, attraction increases means the electron strongly binding with nucleus. To remove an electron, very high energy required for small atoms. So left to right, size decreases, ionization energy increases. So carbon, next, when compared to these two, it is half filled electrons present in 2p, completely filled. It is not half filled. In these two, when compared these two, half-filled electrons containing atoms are highly stable. So to remove an electron, more energy required for stable electronic configuration. So that's why when compared to oxygen, nitrogen, more energy required. So after that, fluorine. So it is first ionization energy. So after removal of one electron, it is converted to 2s2, 2p1. It is 2s2, 2p2. It is 2s2, 2p3. So 2s2, 2p4. So after this, if it is carbon, nitrogen, oxygen, fluorine, to remove an electron from this, less energy required. So size decreases. When compared to these two, again it is more stable because after removal of one electron, it gets a stable electronic configuration, half-filled electrons. That's why oxygen has more ionization energy than the nitrogen. So after nitrogen, so now after fluorine. So answer is C greater than O greater than N greater than F. So options are not given here. So correct order of second ionization enthalpy is C, O, N, F. Next, which of the following are isoelectronic species? Isoelectronic species means same number of electrons. So O minus 2, 8 plus 2. O minus 2 means 8 plus 2, 10 electrons. F minus fluorine 9 plus 1, 10 electrons. Next, sodium 11 minus 1, so 10 electrons. Next, Mg plus 2, here plus 2 means 12 minus 2, so 10 electrons. So all are having same number of electrons. So answer A, B, C and D. Okay. Atomic numbers and a group number, period numbers are given. So the correct answer is 56, atomic number 56. So what is the group number and what is the period number? How to find if atomic number and group number and period numbers are given? So if you know the periodic table, you find group number and period number is very easy. So here one trick. First we have to learn first you have to learn noble gases atomic numbers. Then you find the period number and group number very easy. So how to find the period number and group number? So noble gases: helium. Helium atomic number 2. Neon plus 8, 10. Argon plus 8, 18. Krypton plus 18, 36. Xenon plus 18, 54. Radon 54 plus 32, 86. Oganesson, the last one, 86 plus 32, 118. So we know that after the addition of plus 2, 8, 8, 18, 18, 32, the next elements are occurs. So 2, 10, 18, 36, 54, 86, 118. So first you have to must learn noble gases atomic numbers. By using these atomic numbers, easily find out the remaining elements atomic numbers. So how to find? So the given atomic number 56. What is the nearest value of 56? 54. 54 means 1, 2, 3, 4, 5. Fifth period. So it is the period number. First period, second period, third period, 4, 5, 6, 7. Already we know that 7 periods and 18 groups are present. So xenon is 1, 2, 3, 4, 5. Fifth period. Which group? 18th group element xenon. After 54, next 55 and 56 S block elements. Next two elements are S block elements, 1A group and 2A group. So xenon 5th A group, xenon 5th period, the next elements are 6th period. So 56 is 6th period. So which one? Either second or fourth option. Next, which group? Second group element after 54, 55 and 56, second group elements. 55 first group element, 56 second group element. So second, 6th period and second group and 6th period. So A answer 4. So maybe D or C, A4. So next B. If you see the B, 50. Atomic number 50. What is the nearest value of 50? 54. Again 54. So 54. Before 54, 5 elements are. Only in P block. So total P block, how many groups? 6 groups. So 1, 2, 3, 4, 5, 6 groups. So xenon 54. So 1, 2, 3, 4, 5. Fifth period. 50 also in the same period. So that means fifth period. And which group? If it is 54, if xenon is 54, it is 53, 52, 51, 50. So it is belongs to 14th group. So 14th group and 5th period. 14th group and 5th period. So B is 3. B3. So answer is D. So like that, if you know the noble gas atomic numbers, easily find out the remaining elements. So if 27 up to 20 S block and P block, 21 to 30 D block. So 27 means it is D block. 20 calcium, 21, 22, 23, 24, 25, 26, 27, 27 cobalt, which is 9th period. 27, 9th period. That means C answer 1. So C1. So which period? 4th period. 1, 2, 3, 4. 4th period cobalt is present. It is 9th group and 4th period. Like 58, 54. 5th period, 55, 56, 57, 58. 6th period, 58 means 58. 55, 56, 50. Erythrium, it is lanthanum. it is actinium. So lanthanum, after the lanthanum it is 55, 56, 57, 58 to 14 elements. 14 elements are present in F block. So that means 58th element belongs to F block. That F block is also present in third group. So answer D2. So answer D. So very important. Must and should you learn the first noble gas elements atomic numbers. Easily find out the where that atomic number element is present in period and group. So easily find out this. So not this. So next question. In which of the following molecules are arranged in the increasing order of their bond angles? So NH3SO2 H2O sp3 hybridization. The structure of H2O is angular shape. Here the bond angle 10. Actual sp3 hybridization bond angle is 109 degrees 28 minutes. But due to the presence of two lone pair of electrons, lone pair repulsions, the bond angle decreases from 109 degrees 78 minutes to 104.5 degrees. So next NH3 also hybridization sp3. The shape is pyramidal shape. Here also sp3 hybridization means bond angle 109 degrees 28 minutes. But due to the presence of lone pair bond pair repulsions, the bond angle decreases from 109 degrees 28 minutes to 107 degrees. So here the bond angle 107, here 104.5. SO2 has sp2 hybridization. Here sp2 hybridization means the bond angle 120 degrees. Due to the presence of lone pair, its bond angle is decreases then less than 120 degrees, nearly 119 degrees, like that, 118 degrees. So which of the bond angle is high? So SO2 has a higher bond angle. Next one NH3, next H2O. So note this one. So next, the correct order of decreasing acidic nature of oxides. Lithium, beryllium, carbon, boron, nitrogen are second period elements. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So left to right, metallic nature or non-metallic nature, which nature is increases? The first elements are metals. Left to right, non-metallic nature increases. So non-metallic nature increases. Non-metallic nature increases means non-metal oxides are acidic in nature. So acidic nature left to right, acidic nature increases. So answer Li2O is less than, BeO is less than, B2O3 is less than, CO2 is less than, N2O5. So left to right, non-metallic nature increases, N2O3 or N2O5, whatever it is. So Li2O, BeO, B2O3, CO2, N2O3. So option is 2. Very easy. The next question. Which are the following set of property decreases along a period? So different periodic properties are there. Ionization energy, atomic radius, electron gain enthalpy or electron affinity. Next electronegativity, metallic character, non-metallic character. So top to bottom in groups increases or decreases. In periods left to right increases or decreases. So all the properties see in periods and in groups. The property atomic radius. So next one, ionization energy, electronegativity. En means electronegativity. electron gain enthalpy or electron affinity. Next, metallic nature. Next, non-metallic nature. So in periods, so already you learn this topic in periodic classification of elements, IP level. So in periods, left to right, atomic size decreases. Size decreases means atomic radius decreases. When radius decreases, the attraction between nucleus and valence electron increases. So to remove that electron, more ionization energy required. So ionization energy required. Atomic radius decreases, that means size decreases, electron negativity increases, electron affinity increases. Left to right, non-metallic character increases, metallic character decreases. If you learn in periods, groups opposite to that one. So it is decreases means increases, decreases. So it is decreases means decreases. Here increases, here decreases. In groups, top to bottom atomic radius increases because number of shells increases, like that. So first option, ionization energy and atomic radii decreases. Correct or wrong? Along a period, ionization energy increases. So wrong. Metallic character decreases. Correct. Atomic radii decreases. So atomic radii decreases, metallic character decreases. So answer B. Electron affinity increases. So wrong. Valency and oxidation potential, reduction potential, that is a separate concept. So answer is metallic character decreases and atomic radius also decreases. So option B. Next question. Arrange the following in the increasing order of ionic radii. O-2, Na+, F-, Mg+2. Higher the, these are isoelectronic species. So O-2, 10 electrons, Na+, 11-1, 10 electrons, Mg+2, 10 electrons. So isoelectronic species. For isoelectronic species, higher the negative charge, larger the ionic radii. Next, higher the positive charge, smaller ionic radii. According to this, higher the negative charge, O-2. So higher the negative charge means larger the atomic radii or ionic radii. So next to F-. So next, Mg+2, higher the positive charge, higher the positive charge, smaller ionic radii. So Mg+2 smaller. So next to Na+. So O-. So option is Mg+2, Na+, F-, O-2. So there is no options are given. Next, which of the following sequence is correct for decreasing order of ionic radius? So same model, but negative charges, -2 negative charges are same. Here mono negative charges, here bi-negative charges. So how to decide which one has higher atomic radii or higher ionic radii? I- is the more number of shells, higher. So first write the 7th A group elements: fluorine, chlorine, bromine, iodine. 6th A group elements: oxygen, sulfur, selenium, tellurium. So here iodine number of shells are here 2, 3, 4, 5 shells. Next Se, chlorine, bromine, fluorine. So I- has higher ionic radii. Next, when compared to Se and Br have same number of shells. same number of shells because second, third, fourth period 4 shells are present. Se has higher negative charge. Next Br has lower negative charge. That's why Se minus 2 is also there. So next, when compared to chlorine and bromine, Br has more number of shells. So Br minus more negative. Next Cl minus oxygen and fluorine compare. Cl minus has more number of shells, more ionic radii. When compared to oxygen and fluorine, oxygen minus 2 charge and fluorine less negative charge, F minus O minus 2. So first F minus 2, next O minus 2, next Cl minus, Br minus, Se minus 2, I minus. So which one is correct? F minus, next O minus 2. Cl minus is not there. So Br minus, Se minus 2, so I minus. So option A is correct. So the next one, the successive ionization energies of an element 801, 2430, 3660, 25,000, 32,800 kilojoule molar-hours respectively. The element is. So once you observe, first one 801, next 2400, next 3600, suddenly increases here 25,000. That means it is first ionization energy. That means to removal first electron. For removal of first electron, 801 kilojoules energy required. It is the removal of second electron. It is the removal of third electron. After 3 electrons removal, that element is highly stable. That's why 25,000 kilojoules energy is required. After 3 electrons, removal of 3 electrons, that element is stable. So that means that is converted to noble gas configuration. So which of the element is after removal of 3 elements converted to noble gas configuration? So observe A, boron. Boron atomic number 5. 1s2, 2s2, 2p1. So valence electronic configuration 2s2, 2p. Valence electronic configuration 2s2, 2p1. So after removal of 3 electrons, it is converted to helium gas configuration. It is highly stable. Highly stable means high ionization energy is required. That's why the difference is more. Here 3000, here 25,000. Highest energy required to remove helium gas. So next, carbon 6, 1s2, 2s2, 2p2. After removal of 4 electrons, it is converted to helium gas configuration. So it is wrong. We want only after 3 electrons removal. To remove 4th electron, more ionization energy required. So if 4th one is higher ionization energy value, if 4th one is, the difference is very high when compared to 3rd one, that element contains 3 electrons in their valence shell. So answer boron. So observe oxygen also. Oxygen 8, 1s2, 2s2, 2p4. Here 6 electrons, 6 valence electrons are present. Observe D, nitrogen 7, 1s2, 2s2, 2p3. Here 5 electrons. So after removal of 5 electrons, it is converted to stable gas configuration. But after removal of 3 electrons, it is converted to just fulfilled electronic configuration of 2s, but not it is stable gas. So answer is boron. So answer boron. Very important one. So next one also same model. Starting from the first, the successive ionization potential of an element respectively 5, 18, 28, 120. So here also the difference in third electron to removal of 4th electron, it is first electron removal energy. It is second electron, third electron. After 3 electrons, it is stable electron configuration. To remove 4th electron, 120 electron volts energy is required. That means after removal of 3 electrons element is stable. So which element? So here the answer is here the first option is carbon. After removal of 3 electrons, element is stable. Which one is correct? So carbon is not. If you take aluminum, 1s2, 2s2, 2p6, 3s2, 3p1. So after removal of 3 electrons, it is converted to neon gas configuration. Neon gas configuration. So neon gas configuration, highly stable gas. To remove an electron, very high energy required. So that is 120.1. So answer is aluminum. So not this one.